In our previous video, we looked at predicting whether a solute would be able to dissolve in a solvent based on intermolecular forces. However, there is a limit to any such solubility. Once that limit is achieved, precipitation then occurs. Precipitation is the formation of a solid from a solution. There are three ways of categorizing a solution compared to its solubility limit, or the maximum amount of solute you can get to dissolve in a solvent. A solution that has the solute and solvent in a dynamic equilibrium is said to be saturated. That is, if you add more solute, it will no longer dissolve. The saturation concentration depends on the temperature and the pressure for gases. If a solution has less than this limit, or less solute than a saturated solution, it is said to be unsaturated. For unsaturated solutions, we will be able to add more solute and it will dissolve at the temperature we're working at. We can also, under very careful conditions, produce a solution that has more solute than this saturation limit, and this is said to be a supersaturated solution. When we have a supersaturated solution, often what you'll see is if you drop a single crystal into the solution, then the solute will come out of solution to form a precipitant, forming these crystalline structures. In the lab, there are many useful ways of using this process of precipitation. One of the most common operations performed by a chemist is the removing of impurities from a solid compound. One method of purification involves dissolving a solid in a hot solvent until the solution is saturated. You can then cool that solution until the solid crystallizes back out. Often those impurities that might have been in the solid to begin with remain behind in solution. In order to use solubility and precipitation to perform purification, one needs to know how solubility and temperature interact with each other. Solubility itself is generally given in grams of solute that will dissolve in 100 grams of solvent. Most times the solvent we will be using is water. For most solids, the solubility of the solid increases as the temperature increases. We can see this via the graph on the left, with solubility on the y-axis in terms of grams of solute in 100 grams of water. So as you go up, you're able to dissolve more and more of the solute in water. And on the x-axis is temperature. So typically as temperature goes up, you can dissolve more and more of your solute in your solvent, which in this case is water. We can see here things like calcium chloride. As you increase the temperature, there is a dramatic change in the solubility. Going from 10 degrees to 30 degrees sees a large increase in how much calcium chloride you can get to dissolve in solution. An interesting one is this cerium 3 sulfate, which as the temperature increases, it actually decreases in solubility. So what you would see here is if you had a solution where you had some cerium 3 sulfate dissolved into the solution and you heated it up, more and more solid would form, which is fairly unusual. Again, what normally happens is as you heat up a solution, you'll be able to dissolve more and more of the solute into the solvent. But as this cerium 3 sulfate shows, that is not always going to be the case. The solubility curves can be used to predict whether a solution with a particular amount of solute dissolved in water is saturated, which would be represented by a point on the line, unsaturated, a location below the line, or supersaturated, above the line. Let's look at this for one particular solute. Sodium acetate is one of those solutes that is fairly easy to make a stable, supersaturated solution. Sodium acetate itself is very soluble in water. If we look at the solubility curve, we can see that at 25 degrees Celsius, you can get somewhere around 80-ish grams to dissolve in 100 grams of water. Looking at this diagram, if we then heat the solution, if we heat something that is a saturated solution, then we would be able to dissolve more and more of our sodium acetate in solution. So if we heat it up, we can then get more and more of the sodium acetate to be in solution before we hit this saturated line. So let's say we have a solution that we heated up to 50 degrees Celsius and we managed to dissolve 100 grams of sodium acetate into solution. So we are right here on our solubility curve. And let's say we then cool the solution until we get to here where we meet the saturation line. We would then have a saturated solution. If we further cool the solution and manage to do it very carefully such that a precipitant does not start to form, we would have a supersaturated solution. Sodium acetate is the component that's used in a lot of those instant hot packs where if you bend a piece of foil inside the pack, a crystal begins to form and the solution heats up. If we take a solution that is supersaturated and allow a precipitant to form, the precipitant will continue to form until we fall back to the line of saturation. At that point, the solution becomes saturated and will no longer form additional precipitant.